Good afternoon, everyone. This is another video update from Dr. Rostenberg. I'm going to be talking to you today about estrogen, methylation, and gallbladder. And there's a lot to talk about. We won't get through it all in one video, but I would just encourage you to check out my blog, BeyondMTHFR.com. And all of this information can also be found on the MTHFR support Facebook page. But please support me and just check out my blog. And if you have any questions, that's a good place to ask. Estrogen and methylation are pretty important concepts when you're dealing with working on natural health and working on optimizing your genes and optimizing your lives. I built this slide to show kind of visually what the different effects can be of having an estrogen imbalance. And women and men both need estrogen. Obviously, women need about 10 times more. But in the middle of the bell curve is where optimum health is experienced. This is where symptoms are non-existent and the body is in homeostasis. It's balanced. But on either end of the curve, too little estrogen or too much, there are problems that occur. We will get into some of the reasons why here in this short video. But low estrogen, as you'll see, is related to stroke. It increases the risk of cardiovascular disease. Hot flashes and menopausal symptoms are very common when estrogen levels drop. It affects brain function and certainly mood swings. On the other end of the curve, this is a little more problematic in my opinion. A little more threatening to your health is to have high estrogen. And anyone, male or female, who has COMT genetics that are altered, you're going to have an issue metabolizing estrogen, because estrogen, as you'll see, goes through the exact same COMT pathway, the COMT pathway, as the neurotransmitters. So anything that slows down COMT will slow down the removal of estrogen. And as we'll show in further videos, estrogen is related to blood clots. It certainly makes the blood thicker. It causes venous thrombosis, pulmonary embolisms, all kinds of nasty stuff in the cardiovascular system when estrogen gets too high. It lowers the thyroid function. It promotes anemia, certainly in premenopausal women. Anemia is a big problem. It promotes cancer. Estrogen does cause cells to divide, and sometimes to divide rapidly. Endometriosis, fibroids, and what we're going to focus on today, gallbladder disease. And I'll show you how high estrogen levels can result in gallbladder disease and how we can help that. So methyl stress, meaning inadequate methyl donors, okay, an imbalanced methylation cycle, slows estrogen detox. And this is a picture you can look up online if you Google nutritional influences on estrogen metabolism. There's a mouthful, but if you Google that and go to the images, you can look at this in more detail. I want to draw your attention to this cycle right here. This is the methylation cycle, and what you're seeing is that COMT. It's hard to read. You need to zoom in. But that is the methylation enzyme responsible for breaking estrogen down so that it can go out of your body into the urine and certainly into the bile and out of the gallbladder. And what happens is when COMT is slowed, the body has to then bring estrogen out a different way. And it is sort of, when COMT is slowed, the odds of having carcinogenic and toxic and inflammatory estrogens goes way up. So anyone with a history of breast cancer, prostate cancer, cervical cancer, uterine cancer, testicular cancer, any hormone-sensitive cancer needs to pay attention to this pathway, because it will protect you when you optimize it from further cell division and ultimately be part of your healing. So that's what this chart shows. We will return to this in future videos, but for right now we're looking at the COMT gene, how it's responsible, the enzyme for breaking estrogen down and allowing your body to excrete it. So if your COMT is slow, you will not remove estrogen as fast as you should. That predisposes you to estrogen dominance type of problems. And we look at the gallbladder. This research came up recently, and what I was looking at here is gallbladder and how it's related, how the function of the gallbladder and the liver is related to methylation. And what you're looking at is the cell wall. This is an artist's rendition of the wall of a liver cell, a hepatocyte. And these little abbreviations might be familiar to you: BHMT, PEMT, MAT. This is methionine enzyme. This is betaine homocysteine methyltransferase. This is PEMT. What you're looking at is the methylation cycle in real life, where it lives inside of your cells. So it doesn't just live, we look at this methylation cycle in a two-dimensional chart, but this is where it lives. It lives in the cell wall as well as inside the cell itself. So if anyone has a deficiency in BHMT or some slowness going on with their PEMT enzyme that helps create choline, that creates phosphatidylcholine, they're going to have a problem excreting toxins into the bile. That will predispose someone to being more toxic. And so what you're looking at is how the body, the liver, takes these fats in the cell wall and builds little fat molecules, little droplets where there's a toxin in there that's going into the bile. So this is the process how your body makes bile. Guess what? It's all methylation dependent. This is something we're going to come back to over and over again. And so optimizing your methylation cycle is really important for helping your gallbladder to detoxify itself, as well as all the other downstream effects that come from good gallbladder function. Excess estrogen absolutely causes a gallbladder attack. There's something called intrahepatic cholestasis of pregnancy, ICP. It's common when a woman's estrogen level goes up in pregnancy that the gallbladder becomes more vulnerable. Well, this is what happens. High estrogen levels use up all the methyl groups faster. We just said that estrogen needs methyl groups to be removed, so the more estrogen you have, consequently, the more methyl groups you need. When the body doesn't have access to the methyl groups, what it will do is it will use a sugar molecule instead of a different amino acid to make the bile. And as anyone has tried to pour honey out of a jar or get molasses out of a jar, a lot of sugar in a solution makes it sludgy. So this is what estrogen does. High estrogen causes cholestasis. Okay, that's what you need to know. High estrogen slows down the gallbladder, and you can have a pain pattern shown here. This is a common gallbladder pain pattern. Gallbladder surgery is really very common, which suggests that this problem I'm discussing is also very common, and it's not being fixed, and it should be able to be fixed naturally if you get, in all cases but the most extreme, the gallbladder can be saved. And I will be the first to say that we're not born with any extra parts, so we need to keep everything that we were born with, because it's there for a reason. Now, older women need choline because estrogen is the driving force for your body to make choline from scratch. In other words, if you don't have estrogen in your body, you can't make choline from scratch. Choline, as we'll see, is a very important methyl donor. It helps you optimize your genes. It helps you balance your methylation cycle. As women get older, obviously their estrogen levels drop after menopause, and what this means is that because of lower estrogen concentrations, postmenopausal women need more choline, and many people are not getting enough in their diet. And that's not even touching the idea that there's also genetic SNPs in the choline pathway that increase the requirement even more. So figuring out how much choline someone needs is what we do in our office. So this is not something to necessarily figure out on your own, but reach out for some professional help and we can get you better results in shorter time. Choline is incredibly important. Incredibly important. It is a long-term savings account of all the methyl groups in your body. And choline is real important for white matter, brain function. What do we know about when women age? We know that they become more susceptible to dementia, more susceptible to Alzheimer's. And that's because as their estrogen levels drop, they cannot make choline in the same amount. The diets are off, the lifestyles are off, the gut is off. And this basically hurts our brain. And this is saying the same thing. Choline deficiency disturbs the ability to make myelin, to keep the brain healthy and to grow it and learn new things. One thing that needs to be pointed out too is that this is another example of a cell membrane, and that PCH right there is abbreviation for phosphatidylcholine. Now, this is huge for us in the methylation world. We've got to understand this. Anytime the body does not have enough 5-methyl tetrahydrofolate, anytime there is not enough folate in the body, the next place the body goes to get a methyl group is to the cell wall, aka choline. So when we are not methyl balanced and we have a lot of inflammation, we have toxins, we have Lyme disease, we have co-infections, we have heavy metals, you name it, our need for methyl groups is very high. And without getting the right balance in through our diet and nutrients, our body will be breaking itself apart on the inside. In other words, to mine out the methyl groups that are already in us. We don't want that to happen. So in the case of folate deficiency, SAMe, the requirement for all of our methylation reactions, SAMe is regenerated by the choline oxidation pathway. This is it. Doesn't get any more simple than that. 90% of the choline is inside the cell wall. We want to leave it there. It keeps our cell walls healthy, fluid, and improves all aspects of our being. This is the SNP that is of main concern in the population. The PEMT SNP causes fatty liver. We know that at least 30% of the United States has fatty liver. I'm going to suggest it's closer to 90%. 77, almost 80% of men and 80% of postmenopausal women will develop muscle damage, muscle dysfunction, fatty muscle, and fatty liver if they don't eat enough choline. This is a lot of us. We got to be careful with choline. So you need to work with someone who understands these pathways to get your body optimized. You can take it to the bank that by the time you have fatty liver, you've got a whole host of other methylation and other health and brain problems. These are reversible, but you've got to get on the right plan in order to make the change. This study came out a few years ago, and basically it says that women have increased lifetime stroke risk. Now, this is not true before menopause. Before menopause, women have higher estrogen, they make more choline, they have more methyl groups. Methyl groups lower homocysteine, lower inflammation, multiple ways, help us detox multiple ways, and that protects women from stroke. However, women who had a menopause, surgical or otherwise, before age 42, doubled their risk of stroke compared to all other women. So if you remove estrogen from the body early, and the average age in the United States of a hysterectomy is 37, you remove estrogen from the female body early, you remove the ability for that female to produce methyl groups to protect her from our toxic world, our toxic environment. That will cause an increased risk of stroke. Now, I did mention gallbladder sludge. It's really called bile sludge, guys. And when you have a high estrogen and you have a methyl imbalance, you have gallbladder pain, maybe you've had your gallbladder taken out already. Either way, you still need to nourish that pathway, because even if your gallbladder is gone, it doesn't fix the problem that started it in the first place. And taurine is a critical part of that. Taurine is great for most patients. The only time it would be contraindicated might be with someone with a sulfur or sulfite issue that hasn't yet been addressed. But taurine promotes bile flow. It rescues bile sludge. So anyone who's had their gallbladder out, that means that they've lived in a methyl deficient state for a very long time, and now their body could no longer balance it and manage it, and the gallbladder basically got sick to the point where it had to be removed. We don't have time to get into the other consequences downstream of having your gallbladder removed, and many of you are aware, but we're talking about digestive issues, brain health, detox, hormones, cholesterol, inflammation. It's a big deal. Bile is a big deal, and taurine is our favorite tool in our office for improving bile flow. It's very effective, and the research says as much. So I hope this video has been useful to you. I appreciate your feedback, and this field is growing rapidly, and I show up at work every day to make sure that I get a chance to help people solve their problems, because that's the reward at the end of the day, is knowing that you made a positive difference. So if you're sick, if you're worried, if you're concerned about your health and your life, reach out to me, reach out to somebody through MTHFR support, but don't suffer in silence, and please don't try to figure this all out on your own. You're going to hear me say that over and over and over again. It's even true for doctors. Doctors should not try to treat their whole being and their whole family by themselves, and certainly patients shouldn't. So that's what we're here for. Please reach out. I can be contacted at the email below, and hope that you found this video useful. Thank you.